Okay, in this class we will discuss some problems. That means to find a root of an equation, algebraic or transcendental equation using bisection method. So the main idea is discussed in lecture 1. That is, you have to find 2 points A and B such that f of A and f of B are of opposite signs. Then a root lies in between A and B, that is C, in between A and B. So using bisection method, we will discuss a problem. First one is x square minus 4x plus 2 is equal to 0. Actually this is a quadratic equation, and we know generally to find the general procedure to find the root of the equation. The general procedure is to find the root equation is a quadratic equation for ax square plus bx plus c is equal to 0. Is x is equal to minus b plus r minus square root of b square minus 4ac by 2a. This is a general method to find a root of any quadratic equation. So, but when the degree of the equation is increases, that means a third degree or fourth degree, so it is difficult to find a root of the equation. So now we are doing a simple problem. There is a quadratic equation using bisection method. So the general idea is so first we will discuss, this is the graph of the continuous function. So this is the graph of the continuous function. This is x square minus 4x plus 2, what we are discussing. X square minus 4x plus 2, what we are discussing, the equation. So the equation of the graph of the equation is like this. It touches the point nearly at 0.5 and in between 3 and 3.5. So that means since it is a quadratic equation, it definitely have two roots. The first root is in between 0.5 and 1, and the second root lies in between 3 and 3.5. So that means the graph is like this. So one root is lies in between 0.5 and 1. The second root lies in between 3 and 3.5. So now observe that, say at point 5, the function value is here, f of 0.5, and it is greater than 0. At 1, this is f of 1, which is less than 0, since it is in the negative side of y-axis. And similarly, at 3, the function value is here, f of 3, which is the negative value. And at f of 3.5, it is the function value is here, which is positive. So that means since f of 3 and f of 3.5 are of opposite sign, the root lies in between 3 and 3.5. And similarly, f of 0.5 is positive, f of 1 is negative, the root lies in between 0.5 and 1. So you can find, we are trying to find any one of the root of the equation, but not the both. So first you have to choose the points A and B such that f of A and f of B are of opposite signs. So in this example, you can take A is equal to 0.5 and B is equal to 1, or A is equal to 3 and B is equal to 3.5. So how to verify this using your calculator? So generally your calculator will be like this. So every time it is difficult to calculate the function value at every point. So just enter the equation in your calculator like this. So first press shift alpha, not shift, and click alpha, and here is x, and above closed bracket alpha x gives alpha x and square is here, x square minus 4 alpha and close the bracket x minus 4x plus 2, and press cal C, which is below shift. Press cal C. So now I am assuming x is equal to some 0.5, that is it. That gives the functional value, which is 1/4, which is a positive value. So when I take, again press cal C, when I take x is equal to 1 is equal to, which gives a negative value -1. That means at 0.5 f of a, at 0.5 f of a is a positive value, and b is equal to 1, f of b is a negative value. So that means you have two values a and b such that the root lies f of a and f of b are of opposite signs, then the root lies in between a and b. So here a is 0.5 and b is 1, and f of 0.5 is positive, so I am writing above, and f of 1 is negative. So using bisection method, I am assuming the first approximation is the midpoint, that means x1. So what is the formula? So x1 is equal to a plus b by 2, and clearly you know 0.5 plus 1 by 2 to 0.5 plus 1 by 2, that is so you can calculate in calculator 0.5 plus 1 is equal to 3 by 2, which is divided by 2, use 3.4. So you can that is 0.75. Now what about f of x1? F of x1, whether it is a positive or negative. So again calculate f of 0.75 in your calculator, the function value, that is you can calculate, enter alpha x square minus 4 alpha x, 4 alpha x plus 2, cal C, to enter cal C, at you have to verify at the point 0.75, so 0.75 is equal to, so that is a negative value, it gives minus 0.4375. So you are not required the value, just you have to mention whether it is a positive value or negative, since it is negative value. So I am writing here f of x1 is a negative value, so I am writing below. So now observe that at x1 the function value is negative, at b the function value is negative, that means the root doesn't lies in between x1 and b. Where it lies in between a and x1, because f of a is positive and f of x1 is negative. Let it be x2. So when it lies in between a and x1, by bisection method we will write the formula as x2 is equal to a plus x1 by 2. So every time you can remember, you can mark, that means it is positive and it is negative, so the root lies in between a and b, so mark this one. And you have, now you have x1, which is f of x1 is negative, so cancel the previous negative value, that is f of b. So now the root lies in between, not f of a, f of x1, the root lies in between a and x1, the root lies in between a and x1. So the new approximation value x2 is equal to a plus x1 by 2. Now we have to calculate what is a plus x1 by 2. What is the a? 0.5 plus what is x1? 0.75 by 2. So you have to calculate it. So 0.5 0.5 plus 0.75, which gives 1.25. So divided by 2, so which is 0.625. What is f of x2? So you have to enter the value in the given equation, that is 0.625 square minus 4 into 0.625 plus 2, which is a negative value, which gives a negative value. So now mark it and cancel the previous negative value. Since it is negative value, what is the previous positive value? F of a. So that means the root lies in between a and x2. Since the root lies in between a and x2, what is your new approximation value? x3 is equal to a plus x2 by 2. So that is equal to, what is a? 0.5 plus what is x2? 0.625 by 2. So that means 1.125 by 2, which is equal to 0.5625. So once you are entered the equation and without disturbing it in the calculator, your simplification work will be simple. Observe that I am entering the equation once again. X square minus 4x plus 2. Calci. So I am entering the x3 value 0.5625, 0.5625, which gives a positive value. That means f of x3 is a positive value. Now observe that the new value f of x3 is positive, so the new value always will be marked, and the previous positive value, what is the previous positive value? F of a, which will be cancelled. That means the new marked values are x2 and x3. That means the root lies in between x2 and x3, and your new approximation value x4 is equal to x2 plus x3 by 2. What is x2? 0.625 plus 0.5625 by 2. So you have to add these two. For simplification, I am doing like this: 0.625 125, 5, 7, 8, 11, 1.1875 by 2. So divided by 2 gives 0.5936 7 like this, but I'm considering only 4 digits, so 0.5937. So now what is x4, f of x4? So without disturbing your calculator, just enter cal c. So it asks the value of x. The present value of x is 0.5937, so is equal to gives a negative value, so which is a negative value, and the present negative value will be marked the previous negative value. What is the previous value? F of x2 will be cancelled, and the present marked values are f of x3 and f of x4. So the root lies in between x3 and x4. The value is x5 is equal to x3 plus x4 by 2. So what is x3 plus x4 by 2? So x3 is 0.5625 plus x4 is 0.5937, which is equal to, and is divided by 2, gives 0.57281. 0.5781. So and f of x5 is, so again press cal c, and your x is 0.5781, 0.5781. So that is equal to, which is a positive value. So mark this one and cancel the previous value. So continuing this process, where the successive two approximations are equal. That means since these two are equal, you can write the next approximation. x6 is equal to x4 plus x5 by 2, and which gives x4 is 0.5937 plus 0.5781 is equal to, it is divided by 2, gives 0.5859, f of x6 again enter cal c, 0.5859, which gives a negative value. So mark this one and cancel the previous negative value. So that means the root lies in between x5 and x6. Okay student, I am continued in this problem up to 11th approximation. So up to 11th approximation. So observe the 10th approximation and 11th approximation. It is the two successive approximations are equal up to 3 decimal places. If the question is asked to calculate the approximation root of the equation up to 3 decimal places, it is NF. So finally the root of the equation is x is equal to, we will write the 3 decimal places only. So if the person is asked to find the root of the approximation root of the given equation up to 4 decimal places, you have to continue this problem for x12, x13, 14, 15th approximation, where two successive approximation 4 decimal places are equal. Okay, I hope you understood. Thank you very much.